Good day everyone. Welcome to our lesson week 14. Our specific learning objective today is to explain the propulsive characteristic of a steam power plant based on giving operating parameters. This topic is crucial for understanding marine propulsion. The propulsive characteristic is essential the entire system performance curve. It is defined how the energy from the steam cycle translates into physical force required to move a vessel. To analyze this, we first need a strong foundation on how a steam plant works.
Our first visual aid will guide us through the Rankine cycle and the major components, the boiler, which is where the chemical energy of the fuel is converted into thermal energy, the turbine, which converts thermal energy to mechanical work, the condenser, which creates a necessary vacuum, and the feed pump, which return water to the cycle.
Today, I will try to give you a basic idea about steam power station. A steam power station is also known as thermal power plant. This power generating plant basically works on Rankine cycle. Here, steam is produced in the boiler by coal combustion in furnace. This steam is then expanded through turbine blades. The turbine shaft is prime mover of alternator. Due to this steam pressure, the prime mover of alternator rotates. After expansion, the steam is condensed in steam condenser, and then it again fed to boiler. The rotation of rotor in alternator produces electrical power. These power stations do have some advantages, due to which thermal power plants are most conventional plant for producing electrical power. Such as, number 1, the fuel is coal, and coal is quite cheap in price. Number 2, it involves lesser initial and capital cost compared to hydro and nuclear power plants. Number 3, it involves less space compared to hydro power plant. But, in addition to these, thermal power plants do have two major disadvantages. Number 1, it pollutes atmosphere much due to release of large amount of smoke and fumes. Number 2, its running cost is higher than hydro power plant. This power station mainly involves 7 major arrangements. 1. Coal handling plant. 2. Steam generating plant. 3. Steam turbine. 4. Alternator. 5. Water feeding arrangement. 6. Cooling arrangement. And lastly, the ash handling arrangement. Let us discuss these points in brief one by one. The coal is first transported to the power plant. Then, this coal is stored in coal storage plant. From this coal storage plant, coal is delivered to the coal handling plant. Here, first coal is pulverized. Pulverization is required because it increases thermal efficiency of the coal. This pulverized coal is then fed to the boiler furnace by belt conveyors. The coal is burnt into furnace and produce sufficient heat. Now, come to the steam generating plant. The heat produced in the furnace is utilized to convert water into steam in boiler. The flue gases from furnace make their journey through superheater, economizer, air preheater, and they are finally exhausted to atmosphere through chimney. The steam produced in the boiler is not fully dried. That is why it has to pass through a superheater, where the steam becomes fully dry and superheated much above the boiling temperature of water by the flue gases on their way to chimney. The superheated steam is then delivered to the turbine. After passing through superheater, the flue gas still have some heat energy in it. Some portion of this remaining heat is utilized to heat up feed water to the boiler. Feed water passes through economizer before fed to the boiler. Here the temperature of feed water is increased by extracting heat from flue gases. After extracting heat in economizer, there is still some remaining heat in the flue gases, which can be further utilized to increase the temperature of air before feeding to the furnace for coal combustion. This air heating is done in air preheater by means of flue gases on their way to chimney. Anyway, the superheated steam is forcefully expanded in the turbine and hit the turbine blades. As a result, the turbine rotates with high speed. The rotor shaft of alternator rotates by means of this rotating turbine. Generally, turbine shaft and rotor shaft are coupled together. After doing its work on the turbine blades, the exhausted steam has to be condensed immediately to give space to the steam behind it. This is done in a steam condenser by means of cold water circulation. These condensate from the condenser is fed to the boiler for further cycle. During this cycle, some water may be lost, which is compensated by feeding water from external source. The water circulation is done in the condenser by means of water available in natural sources, like rivers, canals, lakes, etc. The coal is burnt in the boiler, and the ash produced after the completion of combustion. The coal is removed to the ash plant and then delivered to the ash storage plant for disposal.
Following that overview, let's zero in on the steam turbine. In a steam propulsion plant, the turbine is the single most important component for energy conversion. Its efficiency directly determines the ship's fuel economy and maximum speed.
So there's an experiment, a demonstration, an illustration that first shows if we keep this temperature constant what happens to the pressure and the volume. So you observe that when we increase the pressure, our volume decreases. It is an inversely proportional relationship. So since this is clear to us, let's add another parameter. Let's add temperature. In fact, let's add temperature variation. Then things change a little bit. Since during the operation of a steam turbine, the blades that are connected to the wheels, the rotor blades, they absorb part of the energy of the steam. These three basic forms of energy decrease, that is, velocity, pressure, and temperature decrease. There are also these concepts. So let's now analyze how this happens. Let's analyze the profile of a steam turbine blade. You look at it, it has an aerodynamic profile. When fluid, in our case steam with high energy, passes through this pallet, this profile creates a pressure difference. On top it has a higher pressure inside the pallet, and outside a lower pressure. And that effect, aided by Newton's law of action and reaction, it creates a kind of lift force. And that lift force is responsible for making the rotor turn. But the following happens, as we said there, remember? During turbine pressure, the pressure, speed, and temperature decrease. In the steam turbine, what exists is the function of pressurizing the steam to increase or gain kinetic speed. So who is responsible for this? Inside the steam turbines are the diaphragms and the expander plates. But how do they do it? That's what we're going to see now. We need to analyze a little more thermodynamics. If we look at the profile of an expander or diaphragm plate, I'll leave an animation here so we can understand this and how it works. If we are inside a duct with the same area, same pressure, we will see that the fluid has a constant velocity. Whereas when we restrict this passage, strangle this passage, that is, this area, we have a decrease in pressure. However, we have a gain in kinetic velocity. So that's what these pieces do. They give this speed to the steam. And this process even has a specific name. It's called the Venturi effect, named after its discoverer back in 1662. So then we have an animation to demonstrate this there. We have a duct there with a passage with the same area and the same pressure, right? So the fluid will flow there at a constant velocity. The same velocity. Area restriction, that is. We reduce this area, reduce the pressure, we have a gain in kinetic velocity. So as these parts do not have a considerable loss of energy, what happens? The temperature and pressure actually have to decrease to maintain another thermodynamic, actually thermochemical principle, which is the principle of conservation of mass. We have a mass at the entrance and we have to have the same mass at the exit, right? But if we have an increase in speed, the other two automatically have to decrease proportionally. Then what happens? At this moment we have another mounted in the sequence, another wheel, which will do what? It will capture this velocity, this fluid that we are directing. With this increase in speed that it had, it will capture it, and it will go again. It will pass through the vein. It will convert it into kinetic energy and mechanical energy. At that moment again, we will have one more drop in pressure and temperature, and so the process will be repeated for as many stages as there are in the rotor. We decrease the pressure. What happens to the volume? The volume has to increase. That's why in steam turbines, all this flow and this speed of the system, we have to increase it. That's why there in the first stages the pallets are small, and in the last stages, or in the discharge, in the admission it is small, and there in the discharge or in the exit, it has the larger pallets, which is precisely to account for all this flow that it increases to. We keep the speed, otherwise this machine in the last stages would have a very high peripheral speed. These larger pallets will need to support requests for much greater mechanical effort.
Demonstrated, the turbine utilizes alternating rows of fixed nozzles and moving blades. The design is finely tuned to maximize the expansion of steam. It's essentially a series of controlled pressure drops. The total mechanical work, which becomes our propulsive torque, is the cumulative result of these pressure drops across every stage. In marine application, we use a combination of impulse stages driven by steam velocity and reaction stages driven by expanding steam pressure to ensure high efficiency across various power outputs. The propulsive characteristic of the load is defined by the propeller. The power required to push the ship is not linear. It dramatically increases with speed. The propeller law states that the power absorbed by the propeller is roughly proportional to the cube of the shaft rotational speed, and equal P required is proportional to N cube. This means doubling the ship speed require 8 times the power. The power plant characteristic, the power it can deliver, most constantly match the propeller required characteristic. The primary way we controlled this is by adjusting the throttle valve, which modulates the amount of steam flow rate delivered to the turbine. Increasing steam flow increases the available torque, which accelerates the shaft RPM until the turbine's power output precisely equal to propeller's power demand. This intersection point on the curve is the steady state operating condition. The last is condenser pressure. This is often the most critical operating parameter. By maintaining a high vacuum, a very low pressure in the condenser, we maximize the total expansion ratio across the turbine. This maximization is the single most effective way to extract the maximum available energy from the steam, directly boosting the ship's propulsive efficiency and characteristic. A loss of vacuum results in an immediate and significant drop in propulsive power. To deliver this propulsive power effectively, the reduction gear is indispensable. It translates the massive energy of the high-speed turbine into the necessary high torque at low rotational speed required by the propeller to efficiently move the ship through the water. The last is condenser pressure. This is often the most critical operating parameter. By maintaining a high vacuum, a very low pressure in the condenser, we maximize the total expansion ratio across the turbine. This maximization is the single most effective way to extract the maximum available energy from the steam, directly boosting the ship's propulsive efficiency and characteristic. A loss of vacuum results in an immediate and significant drop in propulsive power.
Summary: explaining the propulsive characteristic involved defining the relationship between the plant's steam flow control and the propeller's P required is proportional to N cube requirements, all while optimizing high inlet parameters and maintaining that essential high vacuum. Thank you for your attention.